And begin our chapter on biomass. So, what is biomass? Here's a definition that I pulled. Biomass is any material of recent biological origin. So, examples of this, it's vast, but there's some examples could include crops, forest products, residue associated with crops and forest products, as well as animal fat and food processing waste. Before the start of the 20th century, wood was the primary fuel used, which is a biomass. Biomass is attractive as at least part of the strategy for reducing dependence on foreign oil imports because it is domestic, secure, and abundant. This chapter explores the salient features of biomass and biomass conversion processes. So what is biomass availability? Well, again, this is not an exhaustive list, but they include agricultural crops. So those would be commodities such as corn, soybean, wheat that yield sugar and oils. Another would be agricultural crop residues, such as stalks and leaves of agricultural crops that are not harvested for commercial use. Corn stover consists of the stalks, leaves, husks, and cobs of corn, for example. Then there's herbaceous energy crops. Those are perennials that are harvested annually after reaching maturity. Those are things such as grasses, bamboo. Then there's woody energy crops. These would be hardwood trees harvested within 5 to 7 years of planting. Forestry residues, which are biomass not harvested or removed during logging, and materials removed during forest management operations. Then there's aquatic crops, industrial crops, animal waste, as well as municipal waste from residential, commercial, and industrial sectors. This slide just kind of gives you an idea of different biomass sources. So you have such as examples such as fuel, wood, fuel treatment, logging, oil crops, and they all feed into different areas. So this would be the accumulation of all biomass from forest lands. This would be from agricultural lands, and these would be other secondary and tertiary biomass. And they all feed into the target, which is more than 1 billion tons of biomass resources currently available. This is a map of domestic USA looking at the biomass energy crop suitability by region. So you can see the north, in extreme northwest, you have hybrid poplars, switchgrass in the central US. Northeast, you have willows, hybrid, silver maple, black locust. I'm not going to name every single one. Here's is something interesting: eucalyptus, southern Florida, as well as Hawaii, as well as a little spot in California. So anyway, this gives you an idea of the fact that there's different biomass availability depending on which state you're in. Here you have biomass feedstock source distribution. So you have almost close to a third, but not quite, in perennial crops, 27% in forest resources, almost a third in crop residues, and then corn makes up a small 6%, and all the others added together make up about 8%. So the primary products of interest from biomass processing are as follows. So we have here liquid fuels and gaseous fuels. Liquid fuels are things such as ethanol, which is ethyl alcohol used as a fuel. Methanol, which is an alcohol produced as a byproduct of gaseous fuels. Biodiesel, which is chemically modified from vegetable oils. Vegetable oil itself, and then pyrolysis oil. And then for gaseous fuels, we have biogas, which is a mixture of methane and carbon dioxide, producer gas, and then synthesis gas. What we're going to do is do a little bit more of a review. We're just going to go briefly over these processes and also include an example problem that just kind of helps to illustrate how to quantify the amount of biomass fuel you'll get from a certain biomass reaction. So the U.S. Department of Energy has classified biomass feedstocks to fuels or other products in terms of platforms. So the two primary platforms of biomass and their relationships to feedstocks, processes, and fuels and products are illustrated in this figure here. So the primary platforms of interest for this chapter are the sugar, so biochemical, and syngas, which is a thermochemical. So those two different platforms. And biomass feedstocks are used in both platforms, with the primary output being fuels and chemicals. So let's look at some biomass characteristics. There's three types of chemical descriptions are used to describe the attributes of biomass. So that would be biochemical, proximate, and ultimate. So for a biochemical analysis, that describes an organic compound in terms of proteins, oils, sugars, and fiber. Proximate analysis breaks the compound into its constituents of volatiles, ash, and fixed carbon. And then you have the ultimate analysis, as the name implies, yields components, including several different elements, as well as moisture and ash. I have a series of tables here that I pulled from the book. I'm not going to cover them in detail, but just kind of briefly go over them for illustration effect. So here, this table, it illustrates the biochemical analysis of some common biomass feedstocks. The feedstocks are divided into those that are food-based and those that are fiber-based. As you can see, there's several different types, and it breaks it up in terms of its protein, oil, starch, and basically its components, and gives you um, how much is present. Here, this shows what you would call the proximate analysis of feedstocks. It gives you its higher heating value, so that gives you the amount of heat that it would emit, as well as percentage of volatile ash and fixed carbon. This table here gives you the results of an ultimate analysis for most of the feedstocks listed in the prior table. And then kind of breaks it up into its constituent elements, as well as a percentage of ash. So what we're going to move on to is looking at some biomass-based fuels. Let's first look at ethanol. Ethanol is called ethyl alcohol or grain alcohol, and it's the alcohol in alcoholic beverages. It can be used as fuel in modified internal engines. Ethanol is used also to improve the octane rating and emission characteristics of gasoline, and is commonly used in the form of 10% blend in quote-unquote gasohol called E10. Basically, it means it's 10% ethanol and 90% gasoline. The normal heating value of ethanol as a fuel is typically quoted as 101,000 BTU per gallon, which is basically 3/4 of gasoline on a volumetric basis. So that means basically a motor vehicle that has a gas mileage of 24 miles per gallon on gas would likely have a quote-unquote ethanol mileage of 18 miles per gallon. So for the production of ethanol from glucose, the chemical reaction is as follows. Again, you have the glucose, which yields ethanol and carbon dioxide. Ethanol produced from grains such as corn starts as a water-based slurry. Right, so you have water and grain mixed together to make a slurry. After the starches are converted to sugars, the sugars are fermented into ethanol. In the fermentation process, the enzymes produced by yeast or other microorganisms decompose the sugars into ethanol. and carbon dioxide.